This is the retake video for pre-calculus for the test of sections 4.4 to 4.8, where we had skipped section 4.6. So here's what you need to do if you want to retake. First, you have to check and make sure that you had all of your homework in. Check campus, and you'll see whether or not you had all 2s in there. And as I've discussed with the class, which I hope you've been listening to those daily lesson videos and you already know this, I will go back to the syllabus now, and I will start entering half credit for students that are turning things in late. It's not a punishment, but what's happening is there are too many students that are falling so far behind that there's no way that they can be successful. Math was built to be learned in chunks, and that's what we're supposed to do. Learn a little bit each day, process it so it goes into our long-term memory, learn another little piece of it, and et cetera, et cetera. So make sure that you have those all in. It doesn't matter if they're 2s or 1s, just that you had them all in. And then you follow these steps. Number 1, you watch this video and you take notes on absolutely everything. I want to see details. If I don't see details, then you don't get the retake. That's just how it works. You have to use this time. In fact, other teachers will say, you know, you have to go back and do all the research. You have to find things on the internet. You have to find things in the book. But I'm really trying to help you out a lot here by making this video. And so you need to take advantage of that. I want you to be successful. I want you to do well, but that means you have to put in the work. Number 2, go back in your notes. Highlight the problems that are similar to the test problems. You should be able to find them very easily. You know, we use the notes to guide what we put on the test, and so you definitely should see examples where that's happening. Number 3, redo the day 2 review assignment, since that's the one that's usually closest to what you're going to see on the test, and then take your time and make sure you understand the concepts. Show those details. We spent 7-8 days on graphing, and when I was grading these tests, one person out of both of the classes obviously had just used their graphing calculator. There was another one where I was very suspicious where that had happened. You can't do that. You can't use the graphing calculator when I've spent 7 or 8 days covering all the details of graphing. This is your first year at it, and I need to see those details to know you understand it. Number 4, distance learners, you're going to put all this fantastic stuff from 1 through 3 in a video, and you're going to email me that video by April 5th at 2:45 p.m. with 1 through 3 above completed, no exceptions. And if you send it in at 2:50, I'm going to say, sorry, you know, you knew when the cutoff was. Make sure you're meeting deadlines and getting these things in. Retakes are, they're not a right, they're something that you earn, so make sure that you are following all the guidelines. And in the video, make sure you flip through all the things that you've done to meet steps 1 through 3 up there. And once I've checked that off, I'll get back to you about how we can go about the retake process. Face-to-face learners, we expect that everybody that's here every day will come in and take a paper and pencil test, and I expect that you will come in before April 5th at 2:45 and show me all of the work that you've done for the retake. And then again, we'll talk about, okay, can you make it in tomorrow night after school? We'll schedule all those things. Step 6, deadline for starting that retake is going to be after school on April 6th, which would be a Tuesday. So I have it a little earlier here, 1:45 p.m. for the distance learners, and that's because it usually takes you a little bit longer to make your way through, where's the test, how do I get started, I've got to submit my work, and all that good kind of stuff. So, again, no exceptions on that. So now, this is what you really want to take your notes on here. And we actually had another problem that we added to this test, and I'll explain that later, and that made this out of 53 points. So for number 1, we have the amplitude, the period, the phase shift, the vertical shift, and the range. And I'm going to discuss with you the things that if people missed, they were the most likely culprits. The first thing was people forgot to factor that 3 out. 3 is the B. You have to remember that it's y equals A, and then we have sine or cosine here, and then we have B and x minus h, and all of that plus k. So we have to separate that out because that's going to tell us what the new period will be. The period for sine is usually 2 pi, but this one you're going to factor out that 3, and it'll be 2 pi over b, the absolute value of b, so the period for this one is 2 pi over 3. Now that's the one that we take 1/4 of to figure out what our intervals are going to be. So usually as soon as I've found the period, I go down to this work. And yes, this work is expected. Where's your starting and your stopping points? Normally 0 to 2 pi for sine, but we don't have a normal here. In the parentheses we have 3x minus pi over 2. So we'd put that in between 0 and 2 pi. We'd add pi over 2 to all 3 pieces. We would divide everything by 3, and we would see our graph's going to start at pi over 6, and it should end at 5 pi over 6 for one period. Then you know, hey, I should be starting at that pi over 6, which is my phase shift, pi over 6 to the right. And I take that 2 pi over 3 times 1/4, and that's going to give me what my intervals need to be. So if we have our 2 pi over 3 times 1/4, that's going to give us pi over 6. So we start with pi over 6, and we go in increments of pi over 6, and we get all of that good stuff written down so that we know where those labels have to be. So you have 1 pi over 6, 2 pi over 6 reduces to pi over 3, then you have 3 pi over 6, which reduces to pi over 2, 4 pi over 6, which reduces to 2 pi over 3, and then 5 pi over 6. And those absolutely have to be labeled on your horizontal axis. And on the horizontal axis, we see our biggest denominator, there was a 6. That means we should label according to pi over 6 for each little block horizontally. And then, of course, you have to label your vertical as well. And there were a few people that forgot to label the vertical, but you have to label that because as we go back and take a look at it, we see that this actually has a vertical shift down 2. And then whether or not you wait for the range afterwards or you do it right now, it's going to be from -4 to 0. So once you have it at that spot where everything is labeled, then you look up here and you see that it's sine, and you remember that sine is sahala, which is axis. So there's our new axis with our phase shift and our vertical shift. Axis high, axis low, axis high, and it has to be at those positions that you had for your increments. And then this one said graph 2 full periods, so you also had to go backwards. We always like to see one of the positives and one of the negatives as you're graphing this. So you just follow your pattern. You've got everything labeled already with your little pi over 6s. And then you graph your sine curve. Number 2. And yeah, these were a lot of points because they were supposed to take you longer. You know, the problems after this that don't require graphing and all of this work, they're not going to have as many points. But there are a lot of details in these graphs that we needed to see. So now we move on to 2, which is a tangent graph. And this one doesn't have quite as much going on. But what you have to remember about tangent is to find the new period for tangent, it's pi over b. Pi, 1 pi over b. So this has you figuring out a, which is 1, since there's nothing in front of it there. But the period pi over b, well, b is 1/2. So when you take pi and you divide it by 1/2, you're really multiplying by the reciprocal. So that'll give you 2 pi. And then you go ahead and multiply that into the fourths that we're going to need for our intervals here. So we'll get 2 pi over 4, which is pi over 2. So that's going to be the width that our intervals should be. If, with that, we can fit 2 full periods in here. And you find your starting and your stopping point by originally saying, okay, my asymptotes for tangent are from -pi over 2 to pi over 2. So that's normal, but this one has a 1/2 in front of the x. So then you go ahead and multiply all 3 pieces by 2, and you get a very nice, hey, my asymptotes should be at -pi and pi. And my space in between those should be pi over 2. So you get her all set up, and then you take a look at the fact that we're supposed to tell them the phase shift. Well, there was no H value in this one, so there's none. And then the vertical shift, here's our +1 for K, so up 1. So you could go ahead and put your little helper line on, again, dashed or dotted, never solid, for that vertical shift up 1 if you wanted to. But there was no phase shift, so you don't need a helper going that way. And then you remember that tangent is always increasing over its interval. And then some of you spaced it out a little bit more than I did up here, but you have to be careful because if you use 2 spaces for each of your pi/2 increments, you can't fit 2 full periods on. And you're not allowed to add extra grids to the graph. That's one of those things that when you get to college, they call that amateurish math. You're not showing that you realize, hey, I need to erase this because I have to fit 2 full periods on the space that's given to me. So you never do this, hey, I'll just add one at the end stuff. It doesn't go over well. So there's the tangent graph, again, with all the details, with the x's and the y's being labeled as you go through. And then we get here to the cosecant graph. And our a value in the front, we have a -3, but the absolute value of that is really what a is, and that's going to be 3. That's amplitude. And then b here, the period for this one, cosecant is the reciprocal of sine. And so its period is 2 pi. So you have to take 2 pi, divide it by b, and in this case b is 1, so that means our period is going to be 2 pi. Phase shift, we have it right up there, that x minus pi/4 means we're going to go pi/4 to the right because x always behaves the opposite of what we think it should be. That's the naughty variable. And then we have the vertical shift. There is no k value in the back, so that's a none. Well, if we're going to be talking about what's going on with cosecant, we really have to think about what's going on with sine. And so with sine, we'd think of it as starting at 0 and going to 2 pi. But this wasn't just x, it was x minus pi/4. So you've got your starting and your stopping, and you add pi/4 to all 3 positions, and you see it's going to be from pi/4 to 9 pi/4, which makes sense since we were supposed to have a phase shift of pi/4 to the right. And then you think about your 2 pi, and 1/4 of that would be pi/2. So you start at pi/4 and you add increments of pi/2, and that gets you the new spots where you should have your points, your critical points for your graph. So those will be pi/4, 3 pi/4, 5 pi/4, 7 pi/4, and our biggest denominator is a 4, which means your increments should be in, at the very least, pi/4. So you set that up, and you put on your helpers here, and our helpers would just be the phase shift this time. So that's what you see in what looks like yellow here or green up on the screen. And that's where we would start. And this is sine. So sine would start axis. However, it would normally go axis high for Sahala, but this one has a negative in front, so it has to be reflected. So what was high is now going to be low. So here's my pi/4, there's my 3 pi/4, my 5 pi/4, my 7 pi/4, and then my 9 pi/4, and you follow the pattern backwards. And unfortunately, out of the 2 classes, I did have a couple of people that graphed this as sine. You know, you get that in your head and you just can't get turned around, but this is cosecant, which is a reciprocal, which means any time that we have a point on the axis, that's an asymptote. So you have to go make all of those nice little red dots here, asymptotes, and then turn the graph inside out or upside down, however you want to think of it, and make your little parabolas all over the place there. So I would say probably, I mean, the graphing went really well, especially for the face-to-face students. I would say the biggest thing was there were a couple of people that forgot the reflection. That would probably be about it. Distance learners, you have to watch those videos. You have to see all the detail that we want on all of this. And putting it in the graphing calculator gets you nothing. I'm absolutely nothing. I have to see all of the work that you've done for these intervals. This is not Graphing Calculator 101. It's pre-calculus. So for number 4, we've got cosecant equals the square root of 2. And you have to remember that the square root of 2 comes from the 45, 45, 90. And then this one says it has to be between 3 pi over 2 and 2 pi, and that puts it into 4th quadrant. So we set this up with a 45, 45, 90, so we can see it's 45 degrees. And then we realize, well, at 45 degrees, they said they wanted exact, and this shows us we want this in radians. And this is not an inverse function. This is cosecant of x. So what we have to do is give it its correct name from the positive x-axis. All the way around would have been 8 pi over 4. We need to be 1 pi over 4 short of that for our reference angle, and that's 7 pi over 4. Number 5, 2 cosine of x equals -1. Well, hopefully the first thing you did was divide that by 2, and you think, oh, I need a triangle with a 1 and a 2. That's going to be a 30, 60, 90. And you can't see my x-axis here, but there it is. And the information tells us got to be between pi and 3 pi over 2, which is quadrant 3. And we set it up so adjacent is -1 and hypotenuse is 2. That makes this a 60-degree angle in here, which would be pi over 3. But again, we have to name that from the positive x-axis because this is not an inverse function. So we take a look at it and we say, well, we've got pi plus another pi over 3. That will be 4 pi over 3. Now we start to see the inverses. So this is PVR material here when you start to see the inverses. And we have the square root of 2 over 2, which we need to realize comes from 1 over the square root of 2, or we're going to be choosing the wrong triangle here. That's a 45, 45, 90. And it is positive, so we might as well draw it in first quadrant up here. And then we see, all right, we've got sine, which is opposite over hypotenuse. Obviously, that's going to be 45 degrees, which is pi over 4. And is that in the PVR for sine? And think about your opening the door, and you realize, yep, that's in the PVR. So the answer is pi over 4. For number 7, it's the inverse cosine of negative square root of 3 over 2. So we can't get that in first quadrant because that's negative. So I think about the PVR for cosine, and I realize that has to be over here in the second quadrant. So we draw our triangle. And having that square root of 3 in there means this involves a 30, 60, 90. And we've got cosine, which is adjacent over hypotenuse. That would put our little 1 right here, and that makes this a little 30-degree angle, which is pi over 6. But we have to name that, and with cosine, the PVR is right up here. So we're going to have to name that one 5 pi over 6 to get that in the second quadrant. Remember, you can't leave the PVR to name your angles. Then we've got the inverse tangent of negative square root of 3 over 3. Because it's negative, going to have to go down here in fourth quadrant. And the square root of 3 over 3, hopefully you were thinking, well, that's -1 over the square root of 3. This has to be a 30, 60, 90 triangle. So tangent is opposite over adjacent. Being opposite, our little angle right here being opposite our -1, that's going to be 30 degrees, which makes this pi over 6. We cannot leave the PVR to name it, so we're going to have to name it negative pi over 6. And all of this stuff should be shown on paper. As I mentioned when we did the test originally, don't try to punch anything into the computer. It's going to take you twice as long, and it doesn't give me the quality when I'm looking at your work if you're just giving me part of your answer on the work and then going right to the computer. I want to be able to grade these quickly and get you feedback quickly, and doing the best I can this year, since grading anything on Schoology can take 5 to 6 times as long as grading papers in the classroom. Alrighty, number 9, find the exact value of the composition. So we have the sine of 4 pi over 3, which would be 1 1/3 pi, which takes us over here into third quadrant. which is a problem because we're supposed to find the inverse. So what we have to do is think, well, what would we get here for the sine, and what are we talking about angle-wise? And so for 4 pi over 3, that would make this pi over 3, which is 60 degrees. And I realize that in this quadrant, sine is negative. But to be in the PVR for sine, you have to be in first or fourth quadrant. So we're going to have to move it over here in order to get that negative value that we needed. So this is pi over 3, but I can't leave the PVR to name it, so I have to put a negative in front of that. Now, number 10, there's steps that have to be shown here. And when there are steps that have to be shown, that's how the points are given to you. With this one especially, way too many people just went ahead and ran with it and didn't even do the Pythagorean theorem up here. That's an important part of this problem. You have to show the step of, hey, I knew to set this up so that cosine adjacent over hypotenuse was 5x over 1. Then I had to figure out what the other side length was. So I took a squared plus b squared and set that equal to 1. And here's the part where, again, I had warned you when we did this in class, people are going to write 5x squared, and some people did. It's 25x squared, and then solve for b squared, so you'd subtract 25x squared from both sides, and then take the square root, realizing that we would only use the positive square root because this is a side length. And so now for this other side, we have the square root of 1 minus 25x squared, and we're supposed to find the sine, and sine is opposite over hypotenuse, but the square root of 1 minus 25x squared is just going to be, over 1 will just be 1 minus the square root of 25x squared. 11. Whenever you see a long problem like this with a lot of space for work, you should think they expect to see a lot of work, because we do. We want to see exactly what's going on. And I talked about this when we went through the section where we did a problem almost exactly like this. And what I had said was, you have to give me exact. You cannot give me rounded anywhere while you're doing this problem. That is a big no-no at this level of math. We need it exact. So you can think of these angles as 22.483 repeating and 31.166 repeating, but you can't use that as you go through the math. You have to figure out, okay, what would be the best way to do this? Should I leave it 22 and 29/60ths? Should I leave it 31 and 1/6? But the best math comes from improper fractions. And your calculator does that for you, for goodness sake. You wouldn't even have to think about it. You can put the numbers in and then hit math number 1, and it'll give you those improper fractions of 1,349 over 60 and 187 over 6. And then you look at your drawing and you figure out, well, what do they really want here? You get it all set up and you realize it's x. That's what they want. But I can't find that directly. What I have to do here is the big triangle first, and then subtract. Wait for blue to turn on here. There we go. Subtract the inside triangle, and what's left will be that distance that I have for x. And both of these situations are going to use tangent because this is our opposite and this is our adjacent. So what I'm going to have to do is set this up so that I know that x plus y are involved. Well, for the big triangle, that's the tangent of 1349 over 60 degrees equals 600 over x plus y. And then I solve that so I can figure out what x is, because that's what I want to find. I want x. And I realize, well, I'm going to need y, so I'm going to have to subtract whatever I get for y. And I set that one up, again, exact as 187/6. Improper fractions are exact. And that gives me y. And this is a step that I said when we went over one, like I said, almost exactly like this in class. I have to see that. That is the step that says I knew exactly what I was doing. I'm going to take this exact measure that I get here for my values for x and y, and x plus y to figure out what's missing. And that piece that we need is x. So we have to take 600 divided by the tangent of 1,349/60th degrees minus 600 divided by the tangent of 187 divided by 6 degrees. And then, and only then, do we punch it in. So we don't have any rounding errors as we're working through it. And if you're saying to yourself, well, Cedarholm, I wrote them down as decimals, but I did get the right answer in the end. No, we don't do that. Again, at this level, math is expected to be elegant. Math is expected to be perfect. So we leave it perfect as long as we possibly can. And only at the end do we round to avoid rounding errors and to show anybody that's grading our paper that we know exactly what we're doing. Now, this one was not intended to be a difficult problem, and we took off the line there that said to the nearest tenth of a mile, and we've got a fire is sighted due west of lookout A. The bearing of the fire from lookout B, 9.5 miles due south of A, is north at 45.52 degrees west. And we gave you that, and I think some of you, you just went right away to setting things up because some of you moved that angle up here. It was already on the drawing for you. You didn't have to do any moving. And this was supposed to be a basic kind of SOHCAHTOA problem. And a few people put the 9.5 on the wrong side. And it said right up there that we've got the bearing of the fire from lookout B, 9.5 miles due south of A. So here's A. Due south would be right there. That's where your 9.5 goes. So you're supposed to look at this angle and say, okay, this is adjacent and this is hypotenuse, SOHCAHTOA. That's going to be cosine. So the cosine of 45.52 degrees equals 9.5 over x, and then you'd multiply both sides by x and divide both sides by the cosine of 45.52 degrees. Again, don't skip steps. The algebra here is part of how you get the points for this problem. You cannot skip steps. Now, the very last problem that we added on here. It is unfortunate, but apparently there's a bunch of cheating going on. We've had multiple students that have come back to school with the face-to-face learning, and they said people are bragging because they're able to cheat at home, and so people are going to try and stay home on test days and all this kind of stuff. Wow, is that ever aberrant behavior? And I'm so hopeful, you know, because here's what I know. I don't think any of you would have the character that would create that kind of behavior. I've not seen that. So I'm hoping it was, you know, just somebody making things up and it was rumor and gossip. But we can't just hope that. This is a college level class that's worth 5 credits. That's a lot of money. And the Pine Tech people would not appreciate it if we were giving those 5 credits for free to somebody because you're supposed to earn it. That's how it works. You earn all your points. So Mr. Bloom actually came up with a problem here that uses all the concepts that we know about cosine, sine, tangent, all of our graphs and our sinusoids kind of put together. And we made a real basic one. He made a real basic one here to see, can you put it all together and figure out what A, B, H, and K are. And it's also the type of problem that can't go into photomath. And that was kind of the key, that we had to have a problem on here that there was no way the answer could be obtained by photomath. So B is 16, the range is from 2 to 10, and if you put a 5 into this function, you get a 6. And I just decided to start with the sine. I like that one because it starts at the axis. And the first thing I did was figure out K. K has to be halfway between your lowest and highest values for the range. So 2 plus 10 is 12 divided by 2 is 6. So that meant my K value was at 6. And then I thought, well, how far is that from 10 and how far is that from 2? And that's 4 units. So that's my A value right there. 1 down, 3 to go. Next up, I said, well, they told me, oh, and this wasn't B, this was the period. It was really faded up there. That was the period. So 2 pi over B, because I chose sine, would be 16. And I just solved that to figure out what b is, the absolute value of b, and that would be pi over 8. So far I know that I have an a value of 4, I have a b value of pi over 8, and I have a k value of 6, and I put all of that into my general formula. And my last piece to this is going to tell me what I'm going to need for h, because the information that we were given was that if you put a 5 in, you get a 6. So I went ahead and substituted in x equals 5 and y equals 6. And then I started solving. So I subtracted 6 from both sides, which of course made my little k value disappear. Let me move this up so you can see it. And then I divided both sides by 4, and I had 0 equals 5 pi over 8 minus pi over 8h. So I started thinking, well, when is sine 0? I'd like to use a spot here that would be really super easy, and that happens at 0 radians, because remember, this is cosine and sine. So in order to have it say the sine of 0 equals 0, my 5 pi over 8 minus pi over 8h would have to equal 0. So all I had left to do was to solve that. So I subtracted 5 pi over 8 from both sides, and then multiplied both sides by negative 8 over pi, and that gave me an h value of 5, and that was the last variable that I needed to write my equation. And then I went ahead and graphed it with my graphing calculator to make sure that it met all the requirements that were needed here. So again, it's unfortunate. I am already having you part of a Google Meet. Like I said, I hope it's just rumor. I hope that you're giving this course your all, because it's worth a lot of money, and you need to be earning that grade so you can feel really good about what's going on when you earn those 5 credits. So that is the first part of this, which would be watching this video and taking notes on everything. And then you can go back in your notes now, highlight the problems that are similar to the test problems. Maybe you're doing that while you're watching the video, totally up to you. But you have to take notes on the video. Everything gets written down. And then next thing would be to redo that day 2 assignment and make sure that you let me know before 2:45 on April 5th, hey, I have all this done, could you take a look at it? And we will figure out a time to do the retakes. So good luck, everybody.